Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss dioxygen, means oxygen gas O2. Last class I have discussed anomalous behavior of oxygen. Now I am going to discuss dioxygen. Its preparation. Dioxygen can be obtained in the laboratory by there are many methods to prepare the oxygen gas in laboratory. Few methods I will discuss. First, by heating oxygen containing salts such as chlorates, nitrates and permanganates. These are the oxygen containing salts. Example, chlorate, nitrate and permanganate. Then by heating these salts we can get oxygen gas. Then first I am telling of heating of potassium chlorate, KClO3. Potassium chlorate, KClO3. Potassium chlorate, when it is heated in the presence of MnO2, manganese dioxide, it gives potassium chloride and oxygen gas. Its balanced equation we can write 2KClO3. It will give two product on heating in presence of MnO2. First product is 2KCl, other is 3O2. This is the balanced equation. 2KClO3, it gives two product. First product is 2KCl, other is 3O2. Second method, lab method, I am telling you, by the thermal decomposition of the oxides of metals. Here decomposition of oxide of metals low in the electrochemical series. That oxide should be low in the electrochemical series and higher oxides of some metals that will give oxygen gas. Example, Ag2O, silver oxide. Ag2O, silver oxide, it will give silver plus oxygen. Then its balanced equation is that 2Ag2O, silver oxide, 2Ag2O, it gives 4Ag plus O2. Oxygen is gas, you know. Then by the thermal decomposition of the oxides of metals low in the electrochemical series and higher oxides of some metals, it gives oxygen. And first example is silver oxide, 2Ag2O, it gives 4Ag plus O2. Ag means solid. Second example is lead oxide, Pb3O4, lead oxide, it gives PbO plus O2. Balanced equation is 2Pb3O4. 2Pb3O4, it gives two product, 6PbO plus O2. Third example is mercuric oxide, HgO. On decomposition, it gives 2Hg plus O2. Balanced equation you can write 2HgO. It gives two product, 2Hg plus O2. Hg is liquid, you know. 2Hg plus O2. One more example I am telling you, that is the PbO2. This is also lead oxide. Okay, 2PbO2. and earlier I told Pb3O4, Pb3O4, now I am telling you PbO2. Then 2 PbO2, it will give two product 2 PbO plus O2, 2 PbO plus O2. Lead oxide is solid, don't forget. PbO in both, in Pb3O4 and in PbO2, on decomposition both will give lead oxide, and lead oxide is solid, plus both will give oxygen. Now other method I am telling you, a lab method, that is the hydrogen peroxide. Hydrogen peroxide is readily decomposed into water and dioxygen by catalysts such as finely divided metals and manganese dioxide. Okay, means peroxide, if you will heat it, or you can tell on decomposition, it gives two product, water plus O2, means 2H2O2 in presence of finely divided nickel, finely divided, you can say finely divided nickel and manganese dioxide, both should be present. Okay, hydrogen peroxide is readily decomposed into water and dioxygen by catalysts such as finely divided metals and manganese dioxide. Then 2H2O2, it gives two product, 2H2O plus O2. Okay, 2H2O means liquid. On a large scale, it can be prepared from water or air. Electrolysis of water leads to the release of hydrogen at the cathode and oxygen at the anode. Okay, this is electrolytic method. On large scale, it can be prepared from water or air. Electrolysis of water leads to the release of hydrogen at cathode and oxygen at the anode. Industrially, dioxygen is obtained from air by first removing carbon dioxide and water vapors, and then the remaining gases are liquefied and fractionally distilled to give dinitrogen and dioxygen. Dioxygen means oxygen gas, dinitrogen means nitrogen gas. Both gases you will get. This is the industrial method. Again I am telling you, industrially dioxygen is obtained from air by first removing carbon dioxide and water vapor. This is the removal of carbon dioxide and water vapor from the air. After that, the remaining gases are liquefied and fractionally distilled to give nitrogen and oxygen gas. Now I am telling properties of oxygen gas. Dioxygen is a colorless and odorless gas. O2 is means oxygen gas is colorless and odorless gas. No taste, okay, no odor, no smell. Its solubility in water is to the extent of 3.08 centimeter cube in per 100 centimeter cube, means in 100 ml 3.08 ml oxygen dissolves at 293 Kelvin, 3.08 ml per 100 ml. This is the solubility of oxygen gas in water at 293 Kelvin, which is just sufficient for the vital support of marine and aquatic life. You know that in water, oxygen is required for aquatic life. It liquefies at 90 Kelvin. O2 gas can be liquefied at 90 Kelvin and freezes at 55 Kelvin. See, very important, it liquefies at 90 Kelvin. 90 Kelvin means you understood, I think you might have understood, 273 plus T, that is equal to 90. Then T is equal to what? 90 minus 273. Correct? Then it liquefies at 90 Kelvin. And in degree centigrade, 273 plus T is equal to 90. Then T is equal to 90 minus 273. That it will come under that in minus. Then it liquefies at 90 Kelvin and freezes at 55 Kelvin. Oxygen atom has 3 stable isotopes: oxygen 16, oxygen 17 and oxygen 18. 3 isotopes are there: 16, 17 and 18. Okay. Molecular oxygen means O2 is unique in being paramagnetic. Oxygen is unique in being paramagnetic. Okay, it is paramagnetic actually. It will be attracted towards magnet. Oxygen is unique in being paramagnetic in spite of having even number of electrons. It is even number. Despite that, it is paramagnetic. Oxygen gas means dioxygen directly reacts with nearly all metals and non-metals except some metals. Except some metals like auric means gold and platinum. It will react with all metals and non-metals. And also it will not react with some noble gases. Okay. Dioxygen directly reacts with nearly all metals and non-metals except some metals and some noble gases. Its combination with other elements is often strongly exothermic, means it will release heat, which helps in sustaining the reaction. However, to initiate the reaction, some external heating is required, as bond dissociation enthalpy of oxygen double bond is high, means 493.4 kilojoule per mole. Again you listen. To initiate the reaction, some external heating is required, as bond dissociation enthalpy of oxygen double bond is high, 493.4 kilojoule per mole. That's why heat is required for the reaction, to initiate the reaction. Some reaction I am telling you. Some of the reaction of dioxygen with metals, non-metals and other compounds I am telling you now. Now calcium plus oxygen, you know, it will give calcium oxide, means 2Ca plus O2. 2Ca plus O2, it gives 2CaO. And aluminum will give aluminum oxide, Al2O3. Then 4Al plus 3O2. 4Al plus 3O2, it gives 2L2O3. 4Al plus 3O2, it gives 2Al2O3, aluminum oxide. Next example is P4 plus 5O2. P4 plus 5O2 means P4O10. P4O10 means P2O5, you know, phosphorus pentoxide, double of this, it is a dimer. P4O10 means P4 plus 5O2, it gives P4O10. Next reaction is with carbon, C plus O2, you know, CO2. Next reaction is zinc sulfide plus oxygen gas. It gives two products, zinc oxide plus SO2. Balance equation you can write 2ZnS plus 3O2. It gives 2ZnO plus 2SO2. And next reaction I am telling you methane. With methane, CH4 plus 2O2. CH4 plus 2O2. It gives very simple, it is a very simple reaction. CO2 plus 2H2O. CH4 plus 2O2, it gives CO2 plus 2H2O. Now some compounds reaction I am telling you. Some compounds are catalytically oxidized. For example, 2SO2 plus O2 in presence of vanadium pentaoxide, B2O5, it gives trioxide, 2SO3. 2SO2 plus O2, it gives 2SO3 in presence of B2O5. Next reaction is HCl plus O2. HCl plus O2 means 4HCl plus O2 in presence of cupric chloride, CuCl2. CuCl2. It gives two product, 2Cl2 plus 2H2O. Then this I have told about the reaction. Okay, preparation I discussed, properties also I have discussed, physical properties and chemical properties. Now I am telling about application, means uses. What are its uses? I am telling you now. In addition to its importance in a normal respiration and combustion process actually we take oxygen gas, and in combustion means in burning of wood, any other thing burning, wood, coal, oxygen is required. Then in addition to its importance in normal respiration and combustion, oxygen is used in oxyacetylene welding in the manufacture of many metals, particularly steel. This respiration I told you, combustion also I told you, in there oxygen is required, and oxygen is used in oxyacetylene welding, very very important reaction, oxyacetylene welding. And next, in the manufacture of many metals, particularly steel. Oxygen cylinders are widely used in hospitals, high altitude flying and in mountaineering. Everywhere oxygen is used. Oxygen cylinders are widely used in first hospitals, and high altitude means hilly area. High altitude flying, there also it is used, and in mountaineering. Okay. And next use is the combustion of fuels. The combustion of fuels, as for example, hydrogen in liquid oxygen. Okay. Combustion of fuels like hydrogen in liquid oxygen provides tremendous thrust in rockets. In rockets, fuels are used. That is the hydrogen in liquid oxygen. It is used, liquid oxygen. It provides tremendous thrust in rockets. Okay. Then now I told preparation, properties, means physical and chemical properties, and uses. Now I am going to tell simple oxides. Simple oxides. A binary compound of oxygen with another element is called oxide. What is the oxide? Then a binary compound of oxygen with another element is called oxide. As already discussed, oxygen reacts with most of the elements of the periodic table to form oxides. In many cases, one element forms two or more oxides. The oxides vary widely in their nature and properties. Oxides can be simple, means magnesium oxide as for example aluminum oxide, or mixed. Oxide can be simple oxides or mixed oxides. Then example of mixed simple oxide example I told you: calcium oxide, magnesium oxide, aluminum oxide. Aluminum oxide is Al2O3. And mixed oxide. And mixed oxide means Pb3O4. Why it is mixed? Because Pb3O4 is there, then PbO, it can break into two, PbO and Pb2O3. Two oxides are there. First is the Pb3O4. Pb3O4 can be broken into PbO first and Pb2O3. Like same way, Fe3O4, it can break into two oxide, FeO plus Fe2O3. That's why it is called mixed, because it is the mixture of two oxide. Simple oxide PbO plus Pb2O3. Fe3O4 also FeO plus Fe2O3. That's why it is called mixed oxide. Simple oxide can be classified on the basis of their acidic, basic or amphoteric character. This question is actually asked. It's very, very important things I am discussing. Oxides, many questions are asked on oxide. Then simple oxides can be classified on the basis of their acidic, basic or amphoteric character. An oxide that combined with water to give an acid is termed acidic oxide. Example of acidic oxide is SO2. Second example is Cl2O7. Third example is CO2. Fourth example is N2O5. These oxide on reaction with water, it gives acid. Okay. Again I am telling you, an oxide that combines with water to give an acid is termed as acidic oxide. Example SO2, second Cl2O7, third CO2, fourth N2O5. Okay. For example, I am telling you SO2 combines with water, SO2 plus H2O, it gives H2SO3. This is the acid, H2SO3. Okay, sulfurous acid. H2SO4 is sulfuric acid. As a general rule, only non-metal oxides are acidic, but oxides of some metals in high oxidation state also have acidic character. Listen here, question is asked. Be careful. We listen all the things carefully because many questions are asked. Again I am telling you, as a general rule, only non-metal oxides are acidic. But now see this exception. But oxides of some metals in high oxidation state, okay, also have acidic character. Example, Mn2O7, CrO3, V2O5. If you see the oxidation state of manganese in Mn2O7, then what you will get? Mn2, you don't know what is oxidation state. Then 2Mn plus 7 into minus 2 means minus 14, that is equal to 0, means 2Mn is equal to 14, then Mn is equal to plus 7. See, high oxidation state. CrO3, chromic acid, again Cr is equal to Cr minus 6, 3 into minus 2 means minus 6, then CrO3. Then what is the value of Cr? It is minus 6, it will go left side, right side, it will come plus 6. Plus 6. Chromium has plus 6 oxidation state. V2O5, same way you can calculate. V2O5. O5 means minus 10. Means 2V is equal to plus 10. Then V is equal to plus 5. Then here vanadium has plus 5 oxidation state. Then in higher oxidation state, metal also show acidic character. Now again you listen other things. The oxides which give a base, with water are known as basic oxide. Example, Na2O, CaO, BaO means barium oxide, sodium oxide, calcium oxide, barium oxide, all are basic oxide. For example, CaO, calcium oxide, combines with water to give calcium hydroxide, CaOH2. OH means basic, correct? In general, metallic oxides are basic. Just no. In general way, all metallic oxide in general way are basic. Some metallic oxide exhibit a dual character, dual behavior. They show characteristics of both acidic as well as basic oxides. Such oxides are known as amphoteric oxide. Question is asked, what is the amphoteric oxide? Okay, then some metallic oxide exhibit a dual behavior. They show characteristics of both acidic as well as basic oxide. Such oxides are known as amphoteric oxides. They react with acids as well as alkalis. For example, aluminum oxide, Al2O3. Aluminum oxides react with acids as well as alkalis. This reaction itself is very, very important. This is amphoteric oxide, aluminum oxide, don't forget. It reacts with acid as well as base, means alkalis. Alkalis, actually bases which can dissolve in water is called alkali, correct? All alkalis are bases, but all bases are not alkali. Only those bases which dissolve in water is called alkalis. Okay, then aluminum oxide plus HCl. Aluminum oxide is solid, Al2O3 solid, plus 6HCl plus 9H2O. It will give 2AlH2O whole 6. 3 plus is a complex ion plus 6 chloride ion. Okay, means with acid, aluminum oxide plus 6HCl plus 9H2O, it gives a complex AlH2 whole 6, 3 plus. Okay, 2 in bracket, okay, it means 2 molecules it will give AlH2O whole 6, 3 plus. Here H2O is a neutral ligand. H2O is a neutral ligand. Then this 6H2O, it will go to the vacant d orbital. And aluminum, you know, it has a 3 oxidation state. That's why complex ion is AlH2O whole 6 and power 3 plus, because this 3 plus is not, aluminum has 3 oxidation state. This is not going to be affected by 6H2O molecules which has joined, because it went to the vacant d orbital, and H2O is a neutral ligand. and other product is chloride ion, 6 chloride ion. Hence I am telling you balanced equation now. Al2O3 plus 6 HCl plus 9 H2O, it gives 2 AlH2O whole 6 3 plus. This is the complex ion plus 6 chloride ion. Now you have seen this is the reaction with acid. Now reaction with base, you can see alkali, NOH. NOH, always alkali means water will be there. Okay, you have seen that above also water was there, but here now alkali are talking about NOH. NOH, it is in water. Al2O3 plus 6 NOH plus 3 H2O. It gives only one product. It gives only one product. That is the Na3 AlOH whole 6. AlOH whole 6. Okay. Na3 is the cation and AlOH whole 6, that is here anion. Correct? Then balanced equation I am telling you, that is the Al2O3 plus 6 NOH plus 3 H2O, it gives 2 Na3 and in bracket AlOH whole 6. Now we will ask the question. Now aluminum has only 3 plus, because earlier reaction I told you H2O whole 6 3 plus was there, but now I can say no charge is there, means now it become Na3 means 3 sodium is there, that means 3 plus charge is there. Then aluminum now it is in 3 minus. Aluminum is now in 3 minus. Then how it is possible? It was 3 plus. Earlier I told reaction AlH2 whole 6 3 plus, but now Na3 2 Na3 AlOH whole 6, it is a neutral. How? Then very easily you can understand that now sodium 2 Na3 is there, then 1 sodium means 1 positive, then 2 sodium means 3 sodium means 6 positive, correct, Na3. Then now that aluminum has taken 3 electron. Aluminum has taken 3 electron because now sodium was having 6 positive, but at that time aluminum was having 3 positive. Then 3 positive, 3 negative, it is neutralized. Then extra 3 electron, extra 3 plus is taken by aluminum. That's why it became negative, 3 negative, and now it became neutral. 6 positive was there, 6 positive, 2 Na3 means Na is positive. Then 6 sodium means 6 positive, and aluminum was that time balanced equation you have seen, that was 2 AlH2 whole 6 3 plus. Okay. Then now to neutral, just to make a neutral salt, positive negative should be equal. Then aluminum first it will take 3 plus was there, then 3 electron it will take, then it will become neutral, and extra 3 has taken, then 3 negative. That's why now it became neutral. There are some oxides which are neither acidic nor basic. Such oxides are known as neutral oxide, fourth types, acidic, basic, amphoteric, and fourth type is neutral oxide. Okay, then here this example of neutral oxide, Neutral oxides are neither acidic nor basic. Such oxides are known as neutral oxide. Examples of neutral oxides are CO means carbon monoxide, NO means nitric oxide, and third example I am telling you N2O. Okay, nitrous oxide, nitric oxide, nitrous oxide. Then CO, NO, N2O, all are neutral oxide. Question is asked. Okay. Then now I told about the oxides. Oxides. Now I am going to discuss ozone. O3. Ozone. Ozone is an allotropic form of oxygen. O3. Allotropic form of oxygen. It is too reactive to remain for long in the atmosphere at sea level. Okay, it is very reactive. Ozone is an allotropic form of oxygen. It is too reactive to remain for long in the atmosphere. At sea level at height of about 20 kilometers. 20 kilometers above sea level. At a height of about 20 kilometers, it is formed from atmospheric oxygen in the presence of sunlight. Correct? Means formation of ozone layer, you know, oxygen is required, that also in presence of sunlight. This ozone layer protects the Earth's surface from an excessive concentration of UV radiation. UV means ultraviolet radiation. This is the very important application of ozone layer. Thick layers are there, 200 above the sea level. It absorbs the highly reactive, we can say highly energetic UV light. Otherwise, chances of skin cancer will be there, because now at Antarctica, through that some depletion is there in ozone layer, and some UV rays are coming towards Earth, and due to that chances of this skin cancer increased. That's why nowadays it is advised not to remain in sunlight for long. Now I am talking about preparation. When a slow dry stream of oxygen is passed through a silent electrical discharge, conversion of oxygen to ozone 10% only occurs. You will get only 10%. Okay, conversion of oxygen to ozone occurs. The product is known as ozonized oxygen. Means 3O2 in presence of sunlight I am talking about. 3O2 converts to 2O3. 3O2 means 6. Again 2O3, 6. Then 3O2 converts to 2O3, and it is actually it requires heat. It is endothermic reaction. Then delta H value is 142 kilojoule per mole. Okay. When a slow dry stream of oxygen is passed through a silent electrical discharge, conversion of oxygen to ozone occurs. It will give only 10% less. The product is known as ozonized oxygen. Since the formation of ozone from oxygen is an endothermic process, it is necessary to use a silent electric discharge in its preparation to prevent its decomposition. Okay, delta H value is plus 142 kilojoule per mole. If concentration of ozone greater than 10% are required, A battery of ozonizers can be used. If we want more concentration of ozone, then a battery of ozonizers can be used. And pure ozone has boiling point around 385 Kelvin. Okay, if we want more percentage, means more than 10%, a battery of ozonizers can be used, and pure ozone can be condensed in a vessel surrounded by a liquid oxygen. Liquid oxygen is required. Now, where you are condensing just for condensation purpose, liquid oxygen is required. Okay, then you will get pure ozone, and its boiling point is 385 Kelvin. Today I am stopping only here. Okay, little properties are there, I will discuss, then I will stop. Okay, properties of ozone. Pure ozone is a pale blue gas. Remember, pure ozone is a pale blue gas. Dark blue liquid. In the liquid form it is a dark blue, and violet black solid. In solid form it will be violet black, but in liquid it is the blue, and in gas it is the pale blue. Ozone has a characteristic smell. It has a characteristic smell, and in a small concentration it is harmless. However, if the concentration rises above means about 100 parts per million ppm, if concentration rises above 100 parts per million ppm, breathing becomes uncomfortable, resulting in headache and nausea. Means you can't live there, resulting in uncomfortable and resulting in headache and nausea. Okay, it is not good. High concentration of ozone. Ozone is a thermodynamically unstable with respect to oxygen, since its decomposition into oxygen results in its liberation of heat. When it will decompose, it will liberate heat. Delta H is negative, and an increase in entropy, means delta S is positive. Entropy will increase and delta H is negative. Okay, these two effects reinforce each other, resulting in large negative Gibbs free energy change for its conversion into oxygen. It is not really surprising, therefore, high concentration of ozone can be dangerously explosive. Remember, this high concentration of ozone can be dangerously explosive due to the ease with which it liberates atoms of nascent oxygen. Means O3 will give nascent oxygen, means O2 plus O. O3 gives O2 plus O, nascent oxygen. Due to the ease with which it liberates atom of nascent oxygen, it acts as a powerful oxidizing agent. For example, it oxidizes lead sulfide to lead sulfate and iodide ions to iodine. Reaction I am telling you: lead sulfide plus 4O3, PBS plus 4O3. PBS is solid. PBS plus 4O3, it gives PbSO4 plus 4O2. Second example, 2I iodide ion, 2I plus 4H2O plus O3. Three reactants are there. 2I means iodide ion plus H2O plus O3. It is giving three product, 2OH minus plus I2 plus O2. Correct? Means it acts as a powerful oxidizing agent. When ozone reacts with an excess of potassium iodide solution buffered with borate buffer, I might be knowing borate buffer, its pH is 9.2. Always remember, borate buffer has pH 9.2. When ozone reacts with an excess of potassium iodide solution buffered with a borate buffer, iodine is liberated, which can be titrated against a standard solution of sodium thiosulfate. This is a quantitative method for estimation of O3 gas. O3 gas means ozone gas. Okay. Again you listen, this is important reaction. When ozone reacts with an excess of potassium iodide solution buffered with a borate buffer, iodine is liberated, which can be titrated against a standard solution of sodium thiosulfate. This is a quantitative method for estimation of O3 gas, means ozone gas. Experiments have shown that nitrogen oxide, particularly nitric oxide NO, combine very rapidly with ozone, and there is thus the possibility that nitrogen oxide emitted from the exhaust system of supersonic jet aeroplanes might be slowly depleting the concentration of ozone layer in the upper atmosphere. This is the risky. Depletion of ozone layer is risky. Okay, then jet aeroplane are creating some problems. This is experimentally seen. Experiments have shown that nitrogen oxide, particularly NO, nitric oxide, combines very rapidly with ozone, means NO plus O3. It gives NO2 plus O2. It combines very rapidly with ozone, and there is thus the possibility that nitrogen dioxide, NO2, nitrogen oxides emitted from the exhaust system of supersonic jet aeroplanes might be slowly depleting the concentration of ozone layer in the upper atmosphere. Okay. Another threat, first threat I told that a depletion of ozone layer, jet aeroplane, remember it, due to NO gas. NO plus O3, it gives NO2 plus O2 gas. Another threat to this ozone layer is probably posed by the use of freon, F-R-E-O-N-S, freons, which are used in aerosol sprays as a refrigerant. Freons which are used in aerosol sprays as a refrigerant. The two oxygen bond length in the ozone molecules are identical. O3 are there, then one central atom O is joined with two other oxygen. Then the two oxygen bond length in the ozone molecules are identical, 128 picometer, and the molecule is angular as expected with a bond angle of 117 degree. It is a resonance habit of two forms, means three oxygens are there, then one O in the middle, and it is attached with two oxygen between, and angle is 117. Then actually OO between OO double bond is there, and third oxygen single bond is there. Okay, first two oxygen is double bond and third oxygen is single bond, and in other structure first structure is single bond, first bond with other oxygen is single bond, but For the third oxygen, that is a double bond, means just reversed. Okay, OO in the beginning, in the first structure, OO was double bond, but in second structure that became single, and which was single, that became double. Now just I will tell about application, usage of ozone gas. It is used as a germicide, means it kills the germs. It is also used as disinfectant and for sterilizing water. It is also used for bleaching oils, ivory, flour, starch, etc. Again, I am telling you, it is used as a germicide first, disinfectant second, and for sterilizing water. It is also used for bleaching oils, ivory, flour, starch, etc. Now another application, it acts as an oxidizing agent in the manufacture of potassium permanganate. Now I am stopping only here. Thank you.